So the fourth one here is that we want to ask, what is the net force? So I got to keep talking about the net force because this is what Newton's second law says. And this is a surprise to a lot of people, and it should be a surprise to a lot of people. So the first thing that I want to do here is that I want to remind you what I said earlier. The net force is the sum of all forces acting on an object. So I want to really highlight this. So when you sum all of the forces, all of those forces don't act as individual forces, they act as a single force. So what this is saying here is that the sum of all forces act as a single net force. So objects, so in other words, individual forces are not felt by an object. It only feels the net force. And that is really, really surprising. So what I'm going to do here is that I'm going to draw 3 blocks to try to stress this thing. So I'm going to draw 1 block, and then I'm going to copy it for each of these situations. Nope, let me do this differently. So I have a surface, then I'm going to draw my block. So here is my block. So what I'm going to do now is that I'm going to copy this. And so, because I'm going to need this several times. Okay. Let's look at an example here. So the first case that I want to do here, I want several forces acting on this situation here. So what I'm going to do here is that I'm going to move this over here. And what I'm going to see here is that I'm going to have 2 different forces acting on this block. So let's draw them. Let's say that this force here is F1, and this is 10 newtons. Then I have a second force that's F2, and it's 5 newtons. So what does the net force mean? What that means here is that all of these forces now act as one. So if I come in here and I do my block paste here, what does the object actually feel? Well, we know that the net force is the sum of all of these forces. So this should be F1 plus F2, and that should be 10 plus 5. Why am I adding them? Because they point in the same direction. So the net force is then 15 newtons. So as far as the object is concerned, there's only one force acting on this object. What is this force? The net force is not 10, it's not 5, it's 15 newtons. So just to keep stressing, what I'm saying here is that the block does not feel the 10 Newton force or the 5 Newton force, but only feels, you know what, I'm going to spread this out on the other side because I want to conserve space. Only feels the 15 Newton force. That's it. That's what I mean by that. Now, I can look at other situations of this, and then we'll be a little bit more concise. So now that I've explained one, let's go look at this case here. So what I'm going to do here is that I'm going to come in, and now I'm going to change the directions of the forces. Let's say that I have a force this big. And then I have the force in the opposite direction now. According to Newton's second law here, the net force, because the forces are in opposite direction, it should be F minus F2 because they're in opposite direction. So this should be 10 minus 5. So the net force is actually 5 newtons. So if I look at this thing, I could then come in and just say, hey, look at this block. What does this block feel? It doesn't feel the 5 or the 10. It only feels the net force. And in this case, it feels 5 newtons going to the right. And I can do the exact same situation where now I do something very similar, and it looks something like this here. So what you're seeing here is that now in this situation, I'm going to say that now I have a force that's 10 newtons. Now I'm going to have a different force. Let's call that F3. This is going to be 10 newtons going to the left instead. So according to Newton's second law, the net force in this case is going to be 10 minus 10. It's 0 newtons. This object doesn't feel anything. So we then come over here and nothing happens to that object. So in other words, only 2 situations can give us this scenario here. One, either if the block is at rest, it stays at rest, or if the block is moving at constant velocity, it continues moving at constant velocity. So in summary of this piece here, let me write the following thing. When one states that an object has a 0 net force, it does not mean that no forces are acting on it. There is forces. You could see that there are forces 1 and 3. So what you're finding here is that we see that there are forces, but the result is the net force is 0. So therefore, that object does not feel any forces. Okay, let's go to the last piece, and then we'll go into something deeper here. So the last piece that we want to talk about is we want to talk about the direction. So what we say here is that the acceleration is always in the direction of the net force. So let's look at this scenario here. So what I want to do here is that I want to talk about this picture here. So I want to set up this situation where I have my block. And what I'm going to do here is that I'm going to use a spring. Okay, so that means I'm going to attach a spring that is pulled. So you're going to see here, I'm going to come in here and I'm going to attach a spring. It doesn't have to be a spring, by the way. It could be a string. It could be whatever it is. But you can see here that now what I'm going to do here is that I'm going to apply forces here. If I pull to the right, then I'm going to have a force in that direction. This is to the right. If I pull to the left, then I'm going to pull with the force in that direction. So what this tells me here is that how am I applying a force? Okay, so I touch a spring that is pulled, and the direction of pull tells us the direction of the net force. So let's go do this. Let's talk about speeding up. So if I look at speeding up, imagine the following scenario here. So I have a block, okay? And what do I know about this block? What I'm going to do here is I'm going to say that the block is already moving with the velocity to the right. Now, what am I going to do here? Think about that spring, right? Look at that spring. If I want to make this car go faster, which direction do I have to pull that spring? We see here is that I have to pull to the right. So my net force is to the right. If my net force is to the right, we know we're going to make the car go faster. In other words, the direction of the net force tells me about the direction of the acceleration. So that net force, right? So F net, because of the direction of it, causes the block to speed up. No surprise. Let's do the same thing. But now, instead of speeding up, we're going to talk about slowing down. Now, if I look at slowing down, I got to come in and I got to look at what do I got to do with the spring now? I want to make this thing slow down, but we got to be careful. We know that's the spring rate. I mean, the velocity is going to the right. What do I have to do to the spring to slow down this car? What we do here is that now we attach the spring where? We attach it in the back. And when we attach it in the back, we then say that in this situation here, I can see here that if I'm pulling to the left as the car is going to the right, then the net force is in the opposite direction. What does that do? That makes the car or the block slow down. So in this case, the direction of the net force, we then says F net causes the block to slow down. And look at the direction of the, oh, look at that acceleration. Man, I should be docked and pay for that. That was wrong. Sorry about that. Look at the direction of the net force. Look at the direction of the acceleration. The acceleration is always in the direction of the net force. Now, we're going to go to the next one here, where we're going to talk about turning. This one's harder to see, without any doubt. So what I'm going to do here is that, look what I'm doing. I'm going to put my block. My block is always going to the right. Always going to the right. Now, if I'm talking about turning, what we want to do here is that I'm going to have to take a top view situation of this thing. So now let's look at the block. So if my block was going like this, how do I make the block change direction here? So if they're moving with this velocity, now I need my spring. If I want to make the change in the direction, I have to attach a spring. And so if I wanted to change the direction, I actually have to apply a force perpendicular like this. I have to pull it perpendicular to the direction of motion. So when I come up here to this picture, I'm going to say, I'm going to pull it perpendicular like this. So what does this do here? It forces the acceleration to be perpendicular. And because I have a perpendicular direction, we then say that the net force causes the block to turn. Right? So if I come in here and I write that out, we then say that the net force causes the block to turn. The direction of the net force is the direction of acceleration. Okay. So that concludes Newton's second law.